Good afternoon, everyone. My name is Ray Garrett of the University of Michigan. The title of today's this session is Bringing Outdoor Environments for Improved Utility Asset Management. Our presenter today is Michael Goggin, Director of Geospatial Services, Patrick Engineering. Mr. Goggin is a utility industry leader and geospatial professional with over 25 years' experience applying GIS to improve utility infrastructure management. Clients include public and private electric and gas utilities and institutions. Michael?
Thanks, Ray. I appreciate that. So like Ray said, my name is Mike Goggin. I'm from Patrick Geospatial Services. We're a full-service engineering firm with a professional services geospatial arm to it, kind of focusing in the electric, gas, telecommunications, as well as smart campus, smart facilities. I am admittedly a utility guy. Okay, so my introduction to the campus utilities actually came about 2016. We had a project with a Midwestern university or a university in the Midwest to really kind of take their electric facilities on the campus and migrate them from paper and CAD into a geospatial environment. It was at that point that I really started to draw some conclusions around what's the difference between a utility company managing infrastructure and assets versus a campus or a facility like a manufacturing plant. So this kind of got me thinking quite a bit, actually, with all the background that I have. And then about a year ago, I was fortunate enough to start working with John Young. For those of you who don't know John, he is an ex-Esri person as myself, and he was really integral in, I guess, starting the facility space or business within Esri with a bunch of other intelligent colleagues of his. So we really started to go back and forth, and there's been a lot of evolution in managing assets, specifically network assets, and I'll get into that a little bit. So I'll go through a little bit of a history. I'll share with everyone kind of what's new coming into the pipe. And then I want to share a profound thought that just came up during lunch today. And I think we were kind of talking about it a little bit. How many people in here right now are managing or have all of their electric, gas, communications, steam, water, wastewater managed in GIS right now? Excellent. How many are using a geometric network? Okay, a little less. How many are using the utility network? How many people are aware of the utility network? Okay. I can expand on the utility network. I'm going to share some things with you today, but if you have more questions you want to get down to, feel free to ask me after the session. So like I said, I really started to think about what was the difference of all of these things that I learned managing utilities for 26 years. What is the real difference between a utility company's assets and a campus set of assets? And I think through the campus experience that I had in converting their electrical system, as well as working with John and getting more immersed into a lot of different aspects, the answer is there's really no difference except for maybe scale, right? Size. They're all using the same pad-mounted transformer. The pad-mounted transformer on your left is from a large investor-owned utility, and the one on the right is from a campus setting. They're the same equipment. You all buy the same equipment. You all run it the same way. And you all have very similar drivers, right? And that is really the asset lifecycle. You design, construct, operate, and maintain your assets. Right? Now, I think there's some differentiators, though, between I guess the KPIs, the key performance indicators, the drivers of what make you do what you do to manage and maintain your assets. Like gas and electric utilities, for an example, are highly regulated. Yours may not be. I wish I knew more about that, but I don't, and I apologize. But I think that this is kind of the standard life cycle of an asset in general, and they're very similar. They're the same, actually. Well, what I did observe through my initial engagement with the university And then through working with John over the last year in other university situations and scenarios, is that I think there's a difference potentially in timing and systems. So what do I mean by that? So in the upper left-hand corner, there's paper, there's spreadsheets, and over time, things have been moving into the digital space, right? Then there was CAD and there's spreadsheets. Now, interestingly enough, I think that's where my observation was the largest, is that there's still a lot of campuses that are managing their data like this, the data management aspect of it. And in a lot of cases, those documents are very outdated, to the point they don't trust them, right? So when we were doing work at the university, we wanted to really kind of lay out the detail of the manholes. It was an all conduit and all manholes system. And they basically said, we just can't. We just, unless we open up the manhole, drain it, and get in there, we don't have any documentation to really support. We don't know we have a good idea what's going in. We believe we know what's going out. We don't know exactly where. We don't know what duct. So it would be just kind of an expense that we really don't want to do right now. And then there were several hands obviously up here that are managing, your infrastructure, your assets within GIS framework, which is good. And I'm sure everyone had potentially different reasons for doing that, different drivers, funding mechanisms, et cetera. But I think this is where my biggest kind of differentiator is that most, if not all, the utilities in the country are already on the right-hand side of the screen and evolving further, because their drivers are a little bit different. They're revenue-based, all of them. So trying to get your systems to that level, right, the evolutions, because the utilities have evolved, and they've evolved based on different drivers. So, as the evolution, it started way back, I'd say utility GIS, managing a network, really came into fruition around the mid-90s. Yes, GIS was born, Roger Tomlinson, 60s, Jack Dangerman, 69, founded Esri. But network management, really understanding what networks are, gas, electric, steam, et cetera, really didn't start to hit until the mid-90s when a company out of the UK kind of came in of Small World. They really kind of set the stage for driving competition, which drove Esri to where they are today, which is managing networks better than anyone else, in my opinion. But over that time, the drivers for the utility company that I worked for were outage management. That's the only thing they cared about. They didn't care about asset management. They didn't care about design, construction, nothing, maintenance, nothing. It was all about operations. I've watched those, key performance indicators and the reasons and the drivers of utilities to evolve dramatically over the last, 10 years. When they found out that a geospatial system and geospatial platform can do so much more for their organization. It can be in so many more parts of their organization. They really started to adopt it quite a bit. And now we're at this, the statement that I have here, timely, accurate, and data-rich solutions that are easy to use, easy to deploy, and easy to support with collaboration in mind. Because they're silos, just like I'm sure many organizations are in the campus world as well. So being able to share, data and information across systems in that perspective. The easy to use, easy to deploy, and easy to support, that's our thing. That's kind of our mission statement at Patrick Engineering. We feel that we're user advocates, meaning that it has to be easy. What's the biggest problem with GIS over the last 20 years? It's been difficult to use. Unless you're an ArcMap user and understand a model, right? It's been difficult to use. So now we have, phones and we have tablets, web maps, and just, portals. So it has to be consistent, has to be easy to use and support. Otherwise, nobody would be leveraging it. So GIS is the platform for campus utilities, in my opinion, right? And it sounds like it is for a lot of y'all as well. But if you look at that asset lifecycle, right, there's a lot of things. Now, I only listed several things in each one of the lifecycle things here. So planning and modeling for design, collection of field notes, going out and getting the field conditions, and integration with CAD so that your design solutions, and I won't get into that, that's John's thing, and BIM models, and et cetera. But you go through construction, you have the red lines, what was actually constructed. As-built data collection, this is a huge trend in the investor-owned utility, so the large utility company markets right now. And that is really collecting the data in decimeter level accuracy, X, Y, and Z, in the field when the trench is open, usually for URD, the underground stuff. They're trending in that direction because it's the best way that they can get exactly where the asset is, exactly what the asset was put into the ground or hung on a pole, right? Because a lot of times there's a disconnect between construction and engineering. They may just put in the ground or hang up in the air what they have on the truck. And that was a huge problem for the companies that I've worked with over time. So their systems, their asset systems, as well as their geospatial systems, didn't reflect what was actually in the field. And now they're spending tens and $20 million trying to go out there and field inventory everything. I've got people coming and asking for RFPs to come dig up gas pipe, figure out what it is based on regulations. So, you know, being able to collect that and that trend, especially with the tools like Collector, right, with a Bluetooth connection to an R2 unit, which gets you that decimeter level of accuracy, good data models, and easy to utilize. Operations, so locate assets. This is locate. That was an interesting food line discussion about someone saying that they just dug up a gas line on their campus. And there was so many different reasons why that was no good, right? From safety to cost, the whole bit. It's because they didn't know where their gas lines were. And they need to be able to collect those with more accuracy. And on the back end, when they're doing locating for where they want to do new infrastructure. Damage assessment, outage management, troubleshooting, moving over to maintenance, so the asset management of it. Again, the location of the assets, inspections, analysis and reports. We also had an interesting conversation about preventative maintenance, on how really nobody really does that. If you do, anybody do preventative maintenance? Excellent, fantastic. One. And I probably in the same room of, you know, investor-owned utilities, there would be probably zero. It's hard to justify that for them, big time. So that's where the analysis and the reporting and the real-time information coming back and forth really does help. This will all make sense, I promise you. So really what your ArcGIS platform is that's collaborative decision-making platform. Hopefully you all see it that way as well. Okay, now I'm going to take a step back for a second because I just told you how great ArcGIS was for managing your networks, managing your assets. But I want to put the brakes on right now, and this will lead into the next topic. So this is network management, which is extremely important when you're managing infrastructure. If you want to throw a switch and you don't know what the downstream impacts of throwing that switch is at a breaker or at a switching cabinet, then you have a problem. This was one of the business drivers with the university that we were working with, is they had no idea if they threw a switch what would happen, or if they had a fault, what was the impact to any of their buildings and infrastructure. So until very recently, the way that Esri, ArcGIS managed networks, was through this thing called geometric network. For those of you that are using geometric network, you'll understand this completely. It's an ArcMap based only piece of information. You can't get it anywhere else. It's really kind of the network lives in memory. It's not in a database, so it's not logical. You can't reproduce it unless you have ArcMap. It only understands a connected environment, so everyone understands or has worked with topology before. Find connected, right? It'll find everything that's connected. It won't find something that's a device upstream that is operable, if that makes any sense. Or where can I close a valve in a water system or a gas system? Simple data management tools, they didn't really have the the ability to model and manage networks like transformers, like three-phase transformers, single-phase transformers, switching cabinets, et cetera. They just don't have those tools at that point with the geometric network. Non-industry specific analysis tools, it doesn't have a trace. That's what I was getting. It doesn't have a phase trace. It doesn't have a cathodic protection trace. It doesn't have an upstream trace for a gas or an isolation trace. It just doesn't understand it. And it's difficult to represent a complicated asset like a switching cabinet, right? It doesn't have enough of the data modeling, understanding, and the tools to support it. So when you look at that great platform down there, that is the ArcGIS platform, you're stuck with just managing networks in ArcMap, and you have no access to the apps, Collector, Survey 123, Explorer, Portal, or any of the portal maps and apps. So you can see the information, you can see the data, but you can't do anything with it because it really doesn't understand what a network is. So it really it's been a limiting factor. So for over the last 6 to 8 years, Esri's been working really hard. Before I had left out there, I was working with Bill Meehan a little bit on what they're calling the next evolution of the network, which is where my profound thought comes in when we're talking about indoor GIS as well. So this new way of managing a network, Esri's long game for network management, is called the ArcGIS Utility Network Management Extension. Okay, it's an extension that sits in ArcGIS Pro, but it's also two things. It is data model and it's software. And it is spread through the entire ArcGIS platform. So some of the complicated things we couldn't do before with networks, you can now do. So I kind of broke down, you know, this circle with ArcGIS in the center here with kind of 5 things that I think are things to remember. It's a true network model. So what does that mean? That means that you can model in GIS exactly what is in the field to the level of detail, probably minus nuts and bolts. So it doesn't replace CUs, compatible units, but it will allow you to model a very complex valve station, regulator station, a 3-phase transformer with high side, low side, arresters, fuses, things that you don't normally map for multitudes of reasons. This will allow your analysis to become more granular when you're trying to do, whether it's electric analysis or whether it's gas pressure type analysis. They have network editing and optimization tools. So, you know, I'll jump right to the fact that Esri now understands what a network is, right? It understands what a circuit is, it understands what a subnetwork is, it understands what a pressure zone is. So it has that ability now with tools, you can actually manage the network. You don't need, you know, third-party tools to manage it. It's got the focused analysis and tracing. Because it understands circuits and pressure zones and it understands hydraulics, you can now run your analysis right in ArcGIS, right in ArcGIS Pro. And that extends out to the network everywhere concept. And that means you have network everywhere. In the prior slide I showed where you don't really have the capability through the apps, through the platform, through portal, through collector, but now you do because it understands network everywhere. Now you can do a trace from the field. And one source of the truth. So one of, and you can tell me if this is how it works or how it is for y'all as well, but in the large utility space, they kind of manage all their detailed work like stations and substations and vaults and stuff in separate drawings, right? They may be CAD drawings, they may be paper drawings, service tickets, etc. But with the ability to model such a granular network, you can manage all of that right in your geospatial system now. You don't need to have data all over the place representing visual representation of your system. Have it all in one place. And that will also lead to better analysis and better inspections and better maintenance in asset management. On the right-hand side are our top 10 of feature functions, I guess, of the utility network that we just highlighted. Subnetworks, containment. Containment is important, and I'll go into that a little bit. Associations, diagrams. So anybody's familiar with schematics, ArcGIS schematics, it's now part of ArcGIS Pro. Tracing, so that's the analysis. Network everywhere. 3D, which again leads to my profound thought on indoor GIS and campuses. Editing templates, meaning they have just templates that you can use to add, edit, insert, update, delete, and then attribute rules, right? So these things that'll drive behavior based on entries, right? So if you're in a feature and you're entering a feature in, and it's subtyped, and then that subtype only has certain values in the next pick list, and then the next pick list, and then the next pick list, you don't have to rely on 400 things in a single domain to edit. So that's kind of where the attribute rules come in. So it really does optimize the overall workflow for managing data management. The actual, I guess, domains that they've created or have utility network for are electric, gas, telecom, water, sewer, and stormwater. So somebody asked me about steam yesterday, and I have no idea. I mean, Esri is still working out the details of the telecom, but I'm not quite sure utility network for steam. That's something I'll go back and actually kind of dig into if I can.
That's about steam, chill water, air.
Exactly, right. Yeah, good point. So what I also try to do is I look at it from my view as from a consultant's perspective as business value versus feature function value. So there's a lot of feature functions out there, but they're technology. So how do people justify the cost? Because this is a migration So if you have you're managing your assets right now, the data model is completely different. So I don't know how many features you have inside of your data models today, but for a standard electric or gas utility, they may have 75 to 100 different features. All right, the utility network now is 4. Think of it like points, lines, polygons. That's simplistic, and then everything else is subtyped, right? So a line could be a gas pipe, it could be a water pipe, sewer pipe, etc. So I like to look at it from this, because when you're trying to calculate return on investment, which I've also heard this week, you like to look at these things. How is making the investment here going to make you more efficient in one way, shape, or another? I'm not going to read through all of these, but more efficient and accurate design, that goes along with the integration that Esri and Autodesk have been working on so diligently. If you can use GIS and Geospatial, because it's a more complete model as the backdrop for your design if you're a CAD design shop, or you can do your design right within GIS now with the different ways you can do that. Data source quality improvements. This is breaking the barrier between what's in the field and what's in the office. If you can shorten the time, which is another thing, faster time to market here, what that means is when I'm installing infrastructure, I'm constructing infrastructure and assets, if I have a mechanism that I can actually gather that data in the field and get it back to the office in a day, I think that's considerably better than probably how it is today. Lower total cost of ownership. Event management, right? So events happen on campus involved with infrastructure. You can kind of get there faster. You have more tools at your fingertips, simpler tools, based on standard consumer grade devices like a phone or a tablet. I'm just going to dive into these a little bit, the ones that I think that are important. For me, this is being in the space for as long as I have. This is the most significant change Esri has done in my career, 26 years. The fact and the reality that Esri now understands what a network is and can model it is something they said they would never do. Jack Dangerman said he would never do it. He was going to leave that to business partners, third-party providers, and now he's doing it. So to me, that's significant. And everybody understands circuit subnetwork. They call it subnetwork. It's really a circuit, pressure zone, cathodic protection. It's really anything that makes up a network. We'll leave it at circuit. That's the easiest for me to understand as well. Containment. This one, after we did the work at the campus and saw how we had to model a 7-bay switching cabinet, which has 20 some odd devices within it, in a normal geometric network, in an ArcMap environment, in a smaller campus environment, you can imagine, and you probably have these scenarios to where you're either not modeling at the level of that detail, or you look at it and go, my goodness, that structure is bigger than my building. And it was the same concept when we had indoors, right? We had a, I don't think it was a substation, but it was more of a, a transformer room with some switching cabinets that was on the 4th floor of one of the campus buildings. And it was huge because you have to model it so small, if you want to get it inside the building footprint, but if you model it to where you can actually read it and print it out as a map, it's huge. I don't know if does anybody have that problem that's leveraging this today? So containment allows you to create a separate space. So you can still model your switching cabinet as a single point feature on the map, but when you open what they call open containment, it's really kind of opening up a detailed drawing that's fully connected with some of the other enhancements to the network, that you can now get the level of detail, the 1 to 5 feet, 1 to 3 feet, and you can model everything in there. It's white space management is not a problem. Analysis is not a problem. It's all in real world coordinates. So if you were to put a bounding box on it and say, show me all the transformers or whatever, we provide you with that back. So it just allows you this initial picture up in the upper right is how you would see it on the map as you were looking at it outside of containment. But when you went inside containment, you can see the level of detail there. There's the fuses, there's the high side and the low side, and then there's the transformers and modeled as individual cans, because that's exactly what they are, as individual cans, and that's at a 1 to 5 scale. So again, it allows you to model true real world infrastructure and assets within your GIS without causing a white space nightmare. The other thing I thought about with containment was something that John and I did with our immersive 360 technology was, putting and taking a snapshot of that transformer room or in a manhole or a vault and being able to also leverage that. So a highly, a good visual as well as all the good modeling as well, especially when you're into substations and stuff like that where there's a lot of detail. Tracing, we kind of went over this a little bit. Being able to do a phase trace and upstream trace, is without a third-party tool or writing customizations is a significant upscale for the ArcGIS platform. And again, I can't say strongly enough that that is all over the platform. So if you're in the field and you have a break in a line, water, gas, or whatever, you can actually figure out in the field instead of having to call back to a planner or an engineer to try to figure out what valves I'm going to exercise to isolate whatever it is I need to isolate. Yes, Ray?
It's 5 minutes.
Oh, 5 minutes, thanks. Network everywhere, we kind of covered that. 3D, so this is where I get into my profound thought. Okay, the network, the utility network is now fully 3D enabled. So my thought is this, and that is this is what was our lunchtime conversation, is can we create one data model for a campus that bridges the indoor and outdoor gap? And I know there's been a lot of conversation around data models. Ray and John were having one prior to this session. I think it was the local government data model and how the indoor, data model isn't matching. They had to scrap it. And the data model is a data model. Is what do you want to do with it? How can you get that one campus environment that will allow you to traverse, from indoors to outdoors and be able to, map and see the mechanics that we saw in the prior presentation as it relates to, how the electrical is being fed to the building, the high side, right? Not the outlets, but I'm talking about the transformers and the infrastructure that's supporting the building itself. I think there's a great opportunity. I don't have the answer, and I don't know if this is a great idea, but as I'm thinking about it, my assets, I have to maintain my assets. I've got my facilities, I need to maintain my facilities. Why can't we put our heads together, I think is what Ray said, and kind of figure it out? I don't know if we should let Esri figure it out. I don't know if they will. I don't know if they want to tackle that or not. Maybe they do. But they seem to be focused on indoors and outdoors, not campus. My 2 cents. That's all I had. Any questions? Ray?
So in the utility model, have they really done anything other than the 3D enabling of the data besides taking the minor model and now applied it to the Esri side?
Well, they completely scrapped the minor model completely. It's the data model is, have you seen it? Are you using it? You're not using it, but have you seen it?
We're still using the minor model.
Yeah, I mean, you won't even recognize it. It's that different. Yes, they've redone everything. And why they redid everything in working and talking with the Esri development team is for performance reasons, which was another conversation at lunch when we were talking about the one big data model. Somebody at the table said, yeah, but if it gets too much data in, it's going to be slow. No, it won't. Not in a campus environment. Not when you have utilities at 40 million poles, 250,000 transformers, right? Hundreds and thousands of miles of wire and pipe. Campuses are a perfect environment. In my opinion, this is where I'm excited with John to really kind of take the utility network model and apply it, because I think it's going to make a world of difference, especially when we look at asset management, inspections, and how the platform, the ArcGIS platform, is evolving. Yeah, we don't recognize it, Ray. I mean, I've got 25-year, veterans that are.
So from behind the scenes, it may be 100% different, but it looks like you're doing everything 100% that minor's been doing for the last 10 years.
Yeah, but way different. So when you say like a trace, like a phase trace or something like that, that's the concept. Minor built custom tools, and you have a custom proprietary data model when you apply ArcFM. This is completely out of the box and redesigned so that it didn't need to rely on third party, and it was built for performance and scalability on all devices. So they have to, everything down to collector, it has to perform. And by the way, it's all services based. It's no longer client-server. So ArcGIS Pro is a services-based client, and so is the utility network. So you'll be hitting services, web services, which is why it's platform agnostic.
Do you have any experience converting minor models to this utility model? How difficult is it?
So this was released in January 18th of 2018, and we have partnered with a customer that we are converted their electric and gas, and we're working on their well, not their telco, but their water systems right now. So yes, but nobody in the country from a blanket statement, nobody in the country has gone live with utility network right now. Nobody. There's a lot of people that are working on it because you need a plan. You need a plan. If you're managing infrastructure right now with ArcGIS, and whether you're using geometric network or not, you need a plan because it is not easy. Different tools, different environment. If your shop is an ArcMap shop and you're not using Pro yet, huge change management. Who's using Pro full-time? ArcGIS Pro. Okay. Great tool, but
We did it specifically so that we could try to get into
good strategy because you can take small steps. And I had some, I know I'm done right here, but data readiness, data mapping, change management was a big one for the editors, right? It's a brand new tool. Integration points. If you're an integrated utility, and you will have to go to utility network. It's not an if, it's when. 2024 is your deadline. Just so you know. That's when geometric network will be retired. And theoretically ArcMap.
Can I give the plug here, not only for Mike, but if you guys are wanting to dig into this, PatrickGeospatial.com, he's got a great video that he did right before the recent SRUC. I think that video steps through the considerations and start
Right.
to form your strategy, right?
Yes, the path to the utility network because there's a couple different options.
Thank you very much.
Thank you.